welcome to Math Molecules. This video is part 2 of factorization of polynomials by regrouping. In the previous video, we had learned how to factorize polynomials with HCF, as all the terms had some factor in common. Now let us see how factorization can be performed by grouping or rearranging the terms. So let us try it out with few examples. First one, let's say 3xy minus 3y plus 7x minus 7. So we have these four terms, and in this I see that there is no particular common factor in all these four terms together. 3xy, 3y, 7x and 7. I do not find a common factor. So what I will do is I'm going to group them like this. The first two terms and these two terms, because I see there's something common between them. So for example, if I have got 3xy minus 3y, what do I see common here? I see that there is 3 and y. 3 and y. 3 and y is common. So here I am left with this x. And here it is 1. So this term 3xy minus 3y, these two terms together have been factorized as 3y into x minus 1. So let me just write that here. What did I do is I have factorized this in this way. Now the rest is 7x minus 7. Here I will take 7 as the common factor, and then again I am left with x minus 1. So the plus sign, the same plus sign, I retain it here, and now 7x minus 7 has been factorized as 7 into x minus 1. Now we again see that x minus 1, this term x minus 1 here and x minus 1 here is a common factor in these two terms now. So let's take that common factor out. So if I take this out, I am left with 3y here, and I am left with, this is y, I am left with plus 7 here. So it is x minus 1 into 3y plus 7. So we learned to factorize by regrouping. Why we had to regroup? Because we did not have a common factor in all the terms. So we had to do a little rearrangement. Let's see one more example. Say x square plus xy plus 8x plus 8y. Now again, if I combine these two terms, what do I have common? I have an x which is common. So inside I am left with x plus y. Now when I combine these two, I have an 8 common, and then again I am left with x plus y. Now finally we again have this x plus y which is common factor. So I take out that x plus y, and then here I am left with x. I write the x plus sign, and then I am left with 8. So thus I get the solution, x plus y into x plus 8. Let us take another example. 15ab plus 15 plus 9b plus 25a. Now in this case, if I am combining 15ab plus 15, the first two terms, I see that I have got 15 in common. Perfect. And then I am left with ab plus 1. Now when I combine these two terms, 9b plus 25a, I do not have anything in common here. So it is difficult for me to factorize this way. In such cases, what I'll have to do is I'll have to do a little bit of rearrangement, shift and see. Maybe combine 15AB and 5A, because I feel there can be, certain factors common because it is multiples of 5, and then I'm going to combine this 9B with 15. So 9B plus 15. It's just a trial. Sometime if it doesn't work, you have to again try out a different combination. So here the factors would be 5 into 3 into AB, and here it is 5 into 5A. So the common term here is 5 and A. So I'm left with 3B here, and I'm left with 5 here, plus. In these two, if I see here, it will be 3 into 3 and it will be 3 into 5. So maybe 3 is common here, and then I'm left with 3B plus 5. Now we see that we have got a common factor. So now this common factor is completely taken out, and then we are left with 5A here. The remaining, you just have to write the remaining, 5A plus 3. So thus in this, what we did was we had to do a little bit of rearrangement, shifting the terms here and there to get a common factor. Let's try out another example which involves some negative terms. 5xy minus 4y minus 5x plus 4. Now let's just try taking a common factor by combining these two terms first. So what I see here is the only option I am having is y is common between them. So I'm left with 5x minus 4. Now we see here that it is minus 5x plus 4. But what I want is, the common factor I want is 5x minus 4. The signs are changing inside. The only possibility to have this 5x minus 4 from minus 5x plus 4 is that I might have to take the negative 1 common. If I take minus 1 common here, then I am left with 5x and minus 4. So I take out minus 1 common. Why am I taking out minus 1 common? Because inside I want 5x minus 4, the same factor which we got here. So minus 1, then 5x minus 4. Now we see that 5x minus 4 is common. I take out 5x minus 4, and whatever is left over, y minus 1 is left over into y minus 1. So this is how we had to factorize when we had a negative term. One last example which involves the negative terms. 9x squared plus 3xy minus 12x minus 4y. Now if I combine these two, I have 3x which is common, then I'm again left with 3x plus y. Now here, let me write it separately. Minus 12x and minus 4y. What do I see common in these two is I have got minus 4 which is common. The minus sign itself is common, and that's it. There's nothing else which is common. So if I take out minus 4, I am left with 3x inside and then plus y. Remember, if I take out a negative sign, the signs inside would change. It would be the opposite inside. So minus 4 into 3x plus y. So our aim is to get this factor same. Only then we would be able to take it out as a common one. So 3x plus y into 3x minus 4. We got it. I hope you understood how to factorize by rearrangement. So far in the two parts of factorization of polynomials, we learned how to factorize using a common factor HCF, also how to regroup and find a common factor and then factorize it. Please find the video link for part 1 in the description. I hope this tutorial was helpful to you all. Thank you so much for watching Math Molecules.